Welcome to the SecurityDNA podcast, powered by SecurityInfoWatch.com, where we cut through the noise to bring you the intelligence that matters most. I'm Samantha Schober, Assistant Editor of SecurityInfoWatch and the producer of today's episode. At SecurityInfoWatch, we deliver sharp, real-time insights into the biggest challenges facing security and risk professionals today. From emerging threats to game-changing technologies, we go beyond the headlines to provide expert analysis, real-world strategies, and critical risk intelligence, giving you the knowledge you need to stay ahead in this rapidly evolving landscape. Joining me is my colleague, Steve Lasky, a security industry veteran with over 3 decades of experience. As the editorial director for the security group at Endeavor Business Media, Steve brings deep expertise and a unique perspective to every conversation. And today we have an incredible guest. Steve sits down with Genetec CEO Pierre Racz to dive into the future of security technology, innovation, and the evolving challenges facing organizations worldwide. So let's get started. Pierre Racz is the CEO of Genetec, a privately owned company that develops networked physical security, data analytics, and operational efficiency solutions. Pierre founded Genetec in 1997 with the belief that technology could break down barriers and improve the day-to-day lives of its users. His vision was to develop a physical security system that would enable organizations to take control of their environment. Today, the company develops solutions designed to enhance security, intelligence, and operations for enterprises, governments, and the communities in which we live. As an engineer with over 40 years of experience in the hardware and software development industries, Pierre is closely involved in the company's market vision and product development strategies. Under his leadership, Genetec has grown to employ more than 2,000 staff members, and its solutions are deployed by 42,500 customers in 159 countries worldwide. With that, let's turn it over to Steve.
All right, Pierre. As we were talking earlier, you and I have shared some interesting conversations over the last couple of decades, ranging from technology, future-proofing, Genetec's unique place in the industry, and of course, politics. I propose we steer clear of politics for a bit today. I may throw something in towards the end and concentrate on the industry and technology. But again, it's our pleasure to welcome you here to SecurityDNA.
Thank you very much. It's a pleasure for me to be with you again.
All right, so let's jump into our first question here. This kind of deals with the future of the industry. And, you know, I've always looked at you as sort of a futurist and sort of a security industry Nostradamus. And you and Genetec have played a pivotal role in transforming the security industry from an analog landscape to a network-based solutions provider. But, you know, as the threats continue to evolve at an unprecedented pace, what do you see as the next consequential breakthrough in security technology?
Breakthrough. I don't know. I don't see any breakthrough or anything that's that much revolutionary. In fact, if you're trying to allude to AI, I think that's going to take us a step backwards in terms of the security of security. There's an interesting study that was published early January by MIT, where they found that the first, if you generate code using one of these generative AI systems, the first code that it gives you has a 36% chance of having a security vulnerability. And if you refine the query, the sixth code has, I think, a 43% chance of having a security vulnerability. So it actually gets worse. Since the late 60s, when the term software crisis was first coined, we were always trying to find that silver bullet that's going to slay that werewolf of software development. We've tried all kinds of things, fifth generation, outsourcing, and we're looking for that magic silver bullet. It doesn't exist, and AI is certainly not that magic silver bullet. But you're going to have people that have this wishful thinking and that are going to blindly use it. And the result is going to be either errors in the code or errors in the configuration of governance. And the hackers are using these technologies to actually try to guess at what errors will a company introduce in their digital presence, and they'll drive a truck through it. So maybe that's an anti breakthrough.
Well, I mean, you've shared your perspectives on AI, through the years here, and and often emphasizing the distinction between what we call artificial intelligence and what you refer to as intelligent automation. So,
yes.
So kind of elaborate on, in a landscape where we're dominated with the AI buzz, how is Genetec's and your vision of IA-driven approach cutting through the noise and really challenging all this other, AI hype?
So I don't like the term artificial intelligence because
Right.
artificial intelligence doesn't exist. As I've been quoting Professor Winslow, he said that real stupidity exists, but artificial intelligence does not. So, and actually, he's the one who coined the term IA and told it to me over lunch in 1983. And basically, and so his first PhD was in this field called artificial intelligence at MIT, and so he saw the first failings of this technology, and he defined IA, intelligent automation, as letting the computer doing the heavy lifting, but keeping the human in the loop to provide judgment and creativity. And so that's the way we're using this technology. We are using these statistical inference engines, knowing full well of their incapabilities, and we use them to augment the human capabilities and not to replace the human capabilities.
Right.
So give you an example, one of the many reasons why I dislike the term artificial intelligence is that it anthropomorphizes the technology, and it makes it actually sound as if it's thinking, but it's not. It's a mindless mapping of inputs to outputs. And it's a sophisticated mapping, but it is mindless, and actually there are thresholds of uncertainty below which it cannot go, but it will still provide an answer. And so, for example, these inference engines think that the high probability that 1 + 1 = 2, but they are not certain. So when they provide, they're asked the question, they will provide an answer, but it can be a completely wrong answer. And then we use the anthropomorphic term hallucinates. No, it requires thinking to hallucinate. This
Right.
doesn't do it. It does a random guess, and it doesn't even know that it's doing a random guess. And so putting the human in the loop, the human has to be competent to be able to understand the solution provided by the inference engine and be able to judge whether that solution is credible and that the human wants to basically sign off on that solution. And so that implies that your human is smart enough to understand what they're doing. So to come back to the earlier example I said about people writing code with that, if you have people that are not very good at writing code and they get solutions presented to them by the inference engines, they might not be able to spot the
Right.
errors that are in that code, and then they'll sign off as if a human did it, and then we're in for a world of trouble. As an example, Google does not let engineers with less than 3 years experience use these inference engines. Only senior engineers are allowed to use them to help them write code.
So is this your differentiator between AI and intelligence automation that you profess to kind of embody at Genetec?
I think it's a whole pattern of thought. If you think it's intelligent, then you will. It's sort of like building a bridge. If you think the materials are going to be able to hold the load that you are trying to design for, but
Right.
you're wishing that it does it, well, it's going to be random whether that bridge collapses or not. If you understand the strength of the materials with which you are working, you then can design the bridge such that it will not collapse, and that you will put restrictions on the type of vehicles and the loads and other things that that can go on that bridge. So it's the same thing with these inference engines. When we were using it, there are things that it's good at. It's really good at searching things. It's really good at creating an average of smushing things together. It's actually not too bad to help clarify human thought, which generally we have to work hard to make sure it's not fuzzy.
Right.
But what we can do is use these technologies to take a fuzzy human statement and see if we can map it to a rigorous model. And if we can do it, then we save some time to the human. If the mapping doesn't work out very well, we can prompt the human again, saying, "This is not clear what you said. Can you elaborate on this?" And so, in that sense, we can design systems that are helpful for the human. So, when we're under stress or we're in a hurry, we tend to be a little bit more fuzzy in the orders we give, and so it can help out there. But we mustn't rely on it to think that, I'll let the AI watch the camera and tell me if there's any intruders. That's a bad idea.
Yeah. There seems to be some trepidation within the security industry and in government circles as well about how far we take AI, how much responsibility we give AI, and how much we turn over the car keys to AI in lieu of human control. What are your feelings on that? And do you think there needs to be any type of government oversight or agency oversight? I know here in the U.S. that they were looking at that in the prior to administrations, and it seems now to have been sort of discarded with as much as our cybersecurity infrastructure has been within the last 2 months of the new administration. So, does there need to be government oversight, and how is the Canadian approach different from the U.S. approach when it comes to this technology?
Well, I don't think our approach is that much different. We pretty much think alike on almost all the subjects. With a couple of exceptions I'm sure you want to get to later. So in discussions, there's 3 levels of oversight that could be used. The first one is oversight on the algorithms, and that's not going to work.
Right.
Because we're all using the same algorithms. Basically, nobody has a magic algorithm that's more magic than the other ones. They might be a couple of months ahead, but we eventually figure out how it's done. So doing any regulations on the algorithms is impossible just on the logistical basis, notwithstanding the fact that the legislators themselves don't even understand what we're talking about. So I don't see how they can do something.
Exactly.
The second is restrictions on the training sets. And that's also quite difficult because there's a lot of training sets out there that are for academic use only. And a lot of people just let's see if they catch me using this. And so they use those training sets. So restricting the training sets is a little bit more feasible. For example, there are training sets done by totalitarian governments, China to name them, where they're basically training them on prisoners and slave labor, the Uyghurs. the Uyghurs. Right. And so, again, we can make legislation that tries to restrict that, but it's sort of hard to find out if it's been complying or not. So that's not going to be as useful. But then the third one, which is going to be useful, is to restrict the applications. You should not use these things to, for example, there was a health management organization in the States that was using these machines to withhold care or withhold insurance, resulting in the assassination of the president of that company. I can't remember the name, but
United Healthcare.
Yeah, and so they were rejecting, if I remember, in the order of 32% of the claims versus the industry average, which was more in the order of 15%.
Correct.
And that's an example of, first of all, a bad use of this technology, and second of all, an example of where this technology, where legislation could be applied, legislation and regulations could be applied to make sure that that we don't permit mindless decision making. A human should be in the loop and should sign off on these things, because again, these technologies don't know what they're doing. They're mindless. So if you ask one of these technologies to give you 100 jokes, it'll give you 100 jokes. Ask them which one is funny. No clue.
Right. And it's kind of funny because it's almost anticlimactic, because when some people who really maybe are not as versed in AI as others talk about it, and they say, oh well, but the machine learning part of it is we're teaching this AI to invoke certain actions when a threat or a challenge comes, and we're teaching them to do repetitive things. But the one thing, like you said, we're not teaching them is to be empathetic, to understand the right from wrong, or to understand where you need to make a decision that's not entirely black or white. And I think that's the danger that we have, is that if you're talking about an AI replacing humans, like you said, in this healthcare type environment, you really set yourself up for failure.
Yes, it's interesting because these systems, when we say we're teaching them, they only know what we've trained them on.
Right.
They have no way of generalizing. So, kind of scary after that Tesla accident where the Tesla mowed down this woman in Arizona. Mm-hmm. Another one of those self-driving car companies asked they tried to crowdsource pictures of people pushing baby carriages, because the AI gets confused. It doesn't really know. It doesn't know what it's doing. So if it has never seen that input before, it will not be able to come up with a solution with an arbitrarily set level of confidence of correctness. As I said earlier, it doesn't know that 1 + 1 = 2. It's probable, but it's not sure.
Right.
And crossing this asymptote of assurance it's actually an open research problem. We have an empirical equation that shows that these systems cannot get more certain than that. And we're not entirely sure why, but one thing that we do know is humans cross that asymptote. We can be sure that 1 + 1 = 2. We will assume it. And another interesting thing that is MIT also came out with an interesting study about using the output of the decisions of AI and feed it back to where AI trains itself. And it essentially got progressively dumber and dumber and dumber. So because it cannot generalize, it can average, and it'll average down, and it'll average down to something completely insipid. I think one of the experiments they trained an AI on one of the Beatles song, I think Across the Universe,
Mm-hmm.
had to generate a song. Then they took another AI and then they said, okay, this song generated, it trained it on that one. And they did that a couple of iterations, and a couple of iterations later, the output was so insipid that, I mean,
The song was unrecognizable.
well, not only unrecognizable, unlistenable. It was just garbage.
So, let's switch gears to talk a little bit about cloud technology. I mean, you guys have been at the forefront of this for some time, and most companies, when you're talking about cloud solutions, we're talking about marketing these as a one-size-fits-all solution for cutting infrastructure costs across myriad industries. What do you see as drawbacks in this sort of mindset of, just how we're using the cloud and using it as a one-size-fits-all solution?
All right. Well, so I think it's a result of fuzzy thinking. And so maybe here two things to help us clarify our thinking. We have to separate the economic model from the technology delivery model.
Right.
And so, people are saying, oh, recurring revenue, and that is not synonymous with cloud.
Right.
Also this one size fits all just doesn't work, because what makes organizations unique is that their constraints are unique.
Right.
So they might have telecom constraints, they might have regulatory constraints. All their constraints are different. So our approach is hybrid first. Is not that, oh, cloud is the answer. Is what is the delivery mechanism that you want to use and that you are allowed to use? And then the economic model is, do you want to use, is this an OpEx project or is it a CapEx project?
Right.
And so again, different organizations have different constraints on how they get resources and different constraints on how they manage the resources. So the ability to let the customer choose the system architecture is the future, and it is not all centralized at one central computer. And something that can enlighten us is a movement that is called Web 3.0.
Mm-hmm.
So when I was working in the labs at McGill as an undergraduate student, I got some great jobs there, and what we would do. So even my house was on the internet in 1985 when the university let me put then connect by a serial link to the internet. And so in those days, the computer that you would use as a mail exchanger or FTP server was an old junker in the lab.
Right.
And, oh, this computer, no one wants to use it anymore. Let's make it the mail exchanger. And so that's where the ethos that the internet should be free came from. It was a piece of junk in the lab, required minimum administration. As the internet scaled up, it started to consume more and more resources, both in energy and in computing. Like around 2012, I think internet consumed a little over 10% of all the electricity on planet Earth.
Wow.
So somebody has to pay for that.
Sure.
And so around, in the beginning of the year 2000s, they said, well, we're going to use advertising. First came advertising, then, well, look, we can even make more money if we I'll use the word steal. I'll be controversial. Steal the information that the people don't know the value of. And now the old Silicon Valley people, they say, this is not what we thought it. This is not what we envisaged. And Web 3.0 is using your old junker laptop on which you can install, and the junker laptops that we have today, I have right beside me, I have a pile of them. And, some of them have a tera of storage and a couple of gigs of memory, it can run some stuff. And you download the software and you can use that software to serve the pictures of your family and your recipes to your cousins and whoever you want to share that with. And you can use an inexpensive service to help other people on the network locate your computer. Okay, but all your pictures are on your computer, so you own those pictures, you control it. And maybe that computer is not up 724, but do I really want to pay for 724 computing when I'm serving pictures of my children to the rest of the family? Oh, so we were down 6 hours last night. Power failure. We have crappy power in our area. So that's the Web 3.0. And so more and more organizations actually do want to decide. They say, look, I know how to manage storage. I have to manage all this other storage for our operations. So can you store that video on our servers? And the answer has to be yes. Not you have to put it in the cloud, because putting it in the cloud is more expensive. On the other hand, if you want to do a quick deployment, like this camera has to be up by tomorrow noon, and then are you able to deploy a computer that fast? No, it takes 3 months for our IT department to do it. Okay, cloud is the answer for you for the next 3 months until your IT department can get around to put whatever infrastructure optimization they would like to put in.